I'm going to talk about weed dynamics as influenced by cropping systems and environment. The maize production constraints in Zimbabwe in smallholder farming areas. Maize production in smallholder farming areas is less than 1 ton per hectare, and this threatens food security. Untimely weeding due to labor bottlenecks at the start of the season around November and December contributes to low maize yields. There is estimated crop yield losses of up to 90%. Maize or sorghum monocropping with very little diversification is common. Monocropping leads to low weed diversity dominated by few competitive species, exacerbated by drought and poor soil fertility, low N and P, plus low soil pH. An eco-friendly weed control strategy is needed to release labor during peak periods, maintain high crop yields, and promote weed diversity. For example, mulch plus maize cowpea intercropping. Herbicide technology exists but introduces risks. What we term weed dynamics refer to changes in weed composition, density, or cover caused by cropping system and environment. Weed species richness S is the total number of weeds in a given area. It could be 6 or 15. Shannon-Weiner index is a measurement for diversity, which is between 1 and 7, and above 4 it's considered high diversity. Then species evenness, which is E, it's a measure of how it's a measure of how equal the proportion of each weed species is within the community. Weed density is the number of weeds per square meter. Weed cover is area occupied by weeds per square meter. Weed parameters are commonly calculated using vegan package. Now on the critical weed control, weeds have to be removed around 2 weeks after crop emergence, otherwise there will be serious loss. Then the weeding should be ended probably around 6 or 4 weeks or 6 weeks. That period, CPWC, is known as the critical period for weed control. Now we can only get this type of model when there are sufficient weeds. In fact, when weeds before the crop emerges and with the crop, this is the weed density, which can cause weeds to be removed at 2 weeks after emergence. If there is low weeds at the beginning, weed density, that 2 weeks can be shifted to the left, to the right as follows, or it may disappear altogether depending on the weed density. So the system we are going to talk about, which is maize intercropping plus mulch, has got a tendency to lower weed density rather than shifting the CPWP to the right, making our crops maintain their yields. Now we want to look at the mechanisms of weed control from mulch and maize intercropping. Now, in the bare soil, which could be in the monocrop or intercrop, red light, which is part of white light, will strike the soil surface. Then the red light is absorbed by the seeds. Inside the seeds there is a phytochrome which converts PR to PFR. And the PFR will elevate the level of gibberellic acid and lowers the level of abscisic acid. This breaks dormancy, followed by germination and weed seedling establishment. On the other hand, if you put mulch, you create darkness or you create far red light. This will change PFR to PR, which triggers the increase of ABA and the decrease of GA and leads to dormancy. Once there is dormancy, there is no germination. So it is possible that the mulch can send most of the small seeds into weed seed dormancy. They can sleep for the whole season. Mulch, pre-emergent weed control. The large seeded seeds, these do not require phytochrome system. They can germinate, but they will get etiolated. This leads to starvation and death. In addition, they can also be chemicals which can kill weed seedlings. The maize cowpea intercrop, sometimes we call it a live mulch. This will also produce red light via the canopy, which can send seeds into dormancy. But there are some weed seedlings which can emerge. These will be exposed to far red light. Then their photosynthetic rates is inefficient, producing low carbohydrates, leading to poor growth and reduced competitive ability. Although in extreme cases, this could cause etiolation. This whole system can provide pre-emergence and post-emergence weed control. This could maintain weed density below weed control threshold. The relationship of weed diversity parameters and crop yield. Usually it is a positive linear relationship. For example, with the weed species evenness, if you increase it, you tend to increase crop yield. At the low levels of weed species evenness, there is dominant weeds with strong competition. This is typical of monocropping. it creates dominant weeds. So this is the common situation, and the dominant weeds can actually reduce crop yields. And on a large scale, this can lead to food insecurity, importation of food. But if we change the cropping system to intercropping system, then it changes the weed species evenness, which means there's less competition and high yields. Now the research focus is that cropping system was studied. The cropping systems which were studied were sorrel maize plus cowpea intercrop. Now both systems were evaluated with or without maize mulch, and this was done in Murewa, Mutoko, smallholder farming areas across natural regions 2, 3, and 4 on different soil types: sandy soil, clay soil. In each case, weed density, soil weed cover, as well as diversity were measured. So 2 field experiments were done per each agroecological zone, one on sandy soil and the other on clay soils. This is the area. These are the treatments: sorrel maize plus low mulch rate, sorrel maize plus high mulch rate, maize intercrop on its own, maize intercrop plus low mulch rate, maize intercrop plus high mulch rate. So this is 8 tons per hectare mulch plus cowpea in between the rows. This is just cowpea and maize. This is 4 tons per hectare mulch. The experiments were done under 2 contrasting seasons, wet and dry season. Let's look at the impact of cropping systems and agroecology on weed density, cover, and diversity. This summary of ANOVA table is giving us the effects of main factors and their interactions on 6 parameters: weed density, weed cover, weeding labor days, species richness, evenness, and diversity. You can see that agroecological region, mulch, and cropping system on all the parameters, with the exception of maybe agroecological region on diversity, there were significant effects. The rainy season also significant effects. Then area agroecological region times mulch. Just look where you see stars, it means there's a significant effect. area time, agroecological region times cropping system, mulch times cropping system, which is of our interest really, with all those effects being significant. Weed density, weed cover, labor days, and richness. Now I want to just talk about the main effects on these 6 parameters. We start with weed density. We can see that as far as weed density is concerned, natural region 2 produced the highest weed density, and as we increased mulch rates, we're decreasing density. Intercropping supported low density compared to sorghum maize. Then a more or less similar trend was followed by weed cover. As far as weeding labor, weeding labor days is concerned, the highest labor demand is in agroecological region 2. Then mulching, as you increase mulch, as you add mulching, you decrease weeding labor days. Then monocrop requires more labor days than intercrop. With species richness, as we move to dry areas, richness also decreases. As we add mulch, we decrease species richness. Also, intercropping reduces species richness. Then on evenness, it was in natural region 4 where we have the highest richness, and when we increase mulching, we also increase evenness. Intercropping at the higher richness compared to monocropping. No effects from agroecological region on diversity. As we increase as we add mulch, we tend to decrease with the species diversity. And we also decrease the species diversity in the maize cowpea intercrop. Now, as far as weed density is concerned, where we had maize intercrop, we had the lowest weed density. In fact, even where we added 4 tons per hectare mulch, actually maize cowpea intercrop appeared to suppress the weeds. As we move on to the monocrop, There's a clear effects of adding mulch on weed suppression. On the interaction of agroecological region and the cropping system, we find that maize cowpea intercrop had the highest suppression in agroecological region 4. Then we move on to interaction of mulch and agroecological region. There is a trend in agroecological region 2 which shows that as you add mulch, you tend to decrease the weed density. But if you try to do the same in agroecological 3 and 4, there are no clear trends. Now, weed cover more or less gave us a similar trend like weed density, where we find that in the maize cowpea intercrop, greatest suppression of weed cover at 8 tons per hectare. When we look at the interaction of mulch and the agroecological region, within each natural region, if we take for example agroecological region 2, there's that big response. As you add mulch, you are decreasing the weed cover, and this trend is not that clear in other regions. With the labor days, the maize cowpea intercrop will get the least labor days required. Probably this system can release labor. With weed species evenness, we found that in the maize cowpea intercrop, 8 tons per hectare decreased the evenness, and also the species richness, even in the monocrop. Now, for the cropping system and agroecological region interaction, clear trend in the maize intercrop, where we have agroecological region 4 with the lowest weed species richness, whereas in the monocrop there's no clear pattern. Weed species evenness, now we have got a high weed species evenness in agroecological region 4 for the maize cowpea intercrop. But in the monocrop, it's not that, the differences are not that clear. Now, in the interaction of addition of mulch and agroecological region, now within agroecological region 2, there's a tendency to increase weed species evenness with the addition of mulch, whereas that trend is not that sharp with the other ecological regions. Now, the effects of season on the parameters. The 22, 23, 24 season, a drier season, tended to reduce weed density, weed cover score, weed species richness, Shannon-Wiener diversity index. All these were reduced by the dry season. Now, for the two soil types, it appeared that on sandy soils there was higher diversity compared to the red soil. That is when you look at the weed species richness and the weed Shannon-Wiener diversity index. Our conclusion was that mulching and maize cowpea intercropping, either alone or in combination, suppressed weed infestation across the three agroecological regions 2, 3, and 4 in smallholder farming areas in northeastern Zimbabwe. Mulching and maize cowpea intercropping increased weed species evenness. Maize plus cowpea intercropping and mulching at 8 megagrams per hectare appeared to be the best option for weed suppression via reduced weed density or reduced weed cover, reduced labor days for hand weeding, and increased weed species evenness. So this is it.